Good day, students. Welcome to number one of the AP Calculus AB exam review. We're going to be looking at the free response question from the 2011 examination. In this installment, we're going to be focusing on position, distance, speed, velocity, and acceleration. So let's take a look at problem number one. So question one says that for 0 less than or equal to t less than or equal to 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine e to the t over 4 plus 1. The acceleration of the particle is given by a of t equals 1 half e to the t over 4 cosine e to the t over 4, and x of 0 equals 2. Part A, we are asked, we're told that is the speed of the particle increasing or decreasing at the time t is equal to 5.5? Give a reason for your answer. So is the speed increasing or decreasing? Well, there are two things that we need to determine if the speed is increasing or decreasing. We need to know the sign of the velocity and acceleration. Velocity tells us the direction, and acceleration tells us if the velocity is going to be increasing or decreasing in that direction. Okay? Alright, so there's a chart that you can use to remember the relationship between speed, its change in magnitude, acceleration, and velocity. So what I'm going to do is I'm going to make a coordinate system. I'm going to label my x-axis velocity, and my y-axis is going to be acceleration. Okay, so this side right here is going to be my positive velocity, negative velocity. This is my positive acceleration and negative acceleration down here. Okay, so let's look at the signs. So let's say quadrant 1, you have plus, the velocity is positive and the acceleration is positive. In quadrant 2, velocity is negative, acceleration is positive. Let's put in parentheses so they get confused. In quadrant 3, they are both negative. Velocity negative, acceleration negative. In quadrant 4, velocity is positive, acceleration is negative. Okay, so what do these signs tell us about the speed? If velocity is positive, that tells us that the object is moving forward. Since acceleration is moving in this, has the same sign as the velocity, that means that the object is going to be speeding in that direction. Okay, so in this case, the object is going to be speeding up in the forward direction. Okay, forward direction is because we have positive velocity, and since acceleration is working with velocity, the object is going to be going faster in the direction of the velocity, which is positive, or the right direction along the x-axis. In this quadrant right here, velocity is negative, acceleration is positive. They're working against each other, so the object is going to be slowing down. And in what direction is it moving? This minus means it's slowing down in a negative direction. Okay? Alright, now let's take a look at this situation, quadrant 3. They're both negative, so the object is moving back, and acceleration is working in the same direction with the velocity. So think about backing up with your gas pedal floored completely. So you're going to be speeding up in the backward direction, okay? So since they have the same sign, the object is going to be speeding up in the backwards direction. All right, let's look at quadrant 4. In this case, what do we have? We have velocity is positive, acceleration is negative. They're working against each other. The object is going to be moving forward, but it's going to be slowing down since the acceleration points backwards. So in this case, the object is slowing down in the forward direction. Imagine you're speeding and then you step on the brakes. You're moving forward, but you're going to be slowing down because the acceleration due to the braking and friction is backwards. All right. So this is the chart we're going to use to answer the A part. So for the A part, we need to find the sign of the acceleration and velocity at t equals 5.5. So first thing we're going to do is we're going to evaluate v of 5.5. All right, v of 5.5 is what you get when you plug in 5.5 into the function, which is 2 sine e raised to the 5.5 over 4. So this over 4 plus 1. Okay, let's see what we get with that. And then we're going to also find the acceleration, a of t. No, actually, we're looking at the acceleration when t is equal to 5.5. So that one is going to be the acceleration function, 1 over 2 e to the 5.5 over 4 cosine e to the 5.5 over 4. All right, so let's go ahead and find out what these values are using our calculators. I'll be using the TI-89 titanium and also the TI-83. All right, let's start with the TI-89 titanium. We have to make sure our mode is in radian. So let's enter this expression into the calculator. So we're going to have 2 sine e raised to the, now you have to be really careful when entering this expression right here. We have to enter this in parentheses. So 5.5 divided by 4, close the numerator, close the power, close the exponential function, and then we're going to add 1 plus 1. Diamond enter will give an approximate output. So we have negative 0.45337. Let's make sure it's correct. 2 sine e to the 5.5 over 4 plus 1. Actually, this is the same syntax for entering it into the TI-83, so I don't need to show you that. Okay, so we can see that the velocity is negative, so the object is moving backwards. Now let's enter the expression that will give us the sign of the acceleration. 1 over 2, 1 divided by 2. Let's group that in parentheses. 1 over 2. And then we have e to the 5.5 over 4. 5.5 over 4. So it's that. And then cosine of the same expression. E to the 5.5 over 4. Press enter, and then you get negative 1.35851. Okay, so we can see that both of them are negative, so the object is going to be speeding up or increasing in speed in the backward direction. Okay, so let's write down what our answers are. So for velocity, scroll up a little bit, there you go. Okay, so for velocity we have negative 0.45337, and then for acceleration we have negative 1.35851. So conclusion is the object is increasing in speed, since the sign of the acceleration and acceleration and velocity are the same. Okay, so that's that. Okay, let's take a look at the B part. Part B, we have to find the average velocity of the particle on the time period 0 to 6. So for average velocity is basically an estimation for the instantaneous velocity. So to find the average velocity, what we're going to be doing is using the average velocity formula to determine what the average velocity is. Alright, so let's write down the formula for the average value of a function. We don't want to confuse that with average rate of change, okay? So average value of a function, or f average, on a domain is given by 1 over b minus a times the integral from a to b of f of x dx. Okay? If we're asked to find the average rate of change of velocity or the average acceleration, then we can use the other formula. But this is not the average rate of change. We have to find the average velocity. Okay? So all we're just simply going to do is find the average of the velocity function. So the average of the velocity on that interval 0 to 6 is simply going to be 1 over 6 minus 0 times the integral from 0 to 6 of the velocity function, which is 2 sine 2 sine e to the t over 4 plus 1 dt. Okay, so this is the expression I'm going to plug into our calculators. So let's go ahead and evaluate this using the TI-89 titanium first. So what we're going to do is enter the definite integral. Actually, we can enter 1 over 6 minus 0 is simply 1 over 6. 1 over 6 times the definite integral is simply second function 7, and then enter the function 2 sine e to the t divided by 4, close the power, close the trig function. Variable of integration is t going from 0 all the way to 6. Enter. Give you some seconds to calculate. Alright, so let's see what we have here. Okay, one thing I forget to tell you is every time you enter an expression, look at the pretty print and compare it to what you have to make sure that is the same. And we can see it's slightly different. I didn't put the plus 1. So always cross-check your entry with what the problem is. Enter, that's the beauty of the TI-89 titanium. It shows you what you entered and the answer separately, so you can easily determine if what you entered is in fact correct. Okay? So the plus 1 should be outside. Let's fix that. So it's supposed to be plus the whole thing plus 1. Enter. Alright, so there you go. 2 sine e to the t over 4 plus 1 dt. And you get 1.9494938. Okay? If you want to enter this using the TI-83, same process, but you just have to use a different function. Here, you just go to the catalog, which is second function 0, and then you look for fn function int, go to f, scroll down to fn enter the function that you're entering. So it's going to be, well, let's put in the 1 over 6 first. So parentheses 1 divided by 6, and then catalog fn int. Alright, so fn int, we have 2 sine e to the t over 4. So in this case, it's just x over 4. Now we close the power, close the trig function, and then we add 1. Okay? And then variable of integration is x, starting from 0 all the way to 6. And then you press enter, and there you go. Okay, so that goes the answer, 1.94938. Okay, so that's the average velocity. Let's write it down. So average velocity is 1.94938. Okay, now let's take a look at part C. Part C says find the total distance traveled by the particle from t equals 0 to t equals 6. Notice that distance and position are two entirely different things, okay? Distance and position are different. Position is a vector quantity and distance is a scalar quantity. Alright, just as speed and velocity are two different things. We want to keep in mind the fact that distance and position are two different things. So what's the relationship between position and distance? The absolute value of your position function, x of t, will give us your distance. Okay, let's call that d of t if you want to do that. So applying the absolute value to your uh, position will give you distance. Also, the absolute value of velocity is your speed. Okay, so keep that in mind. Now, to find the total distance, we do not want the velocity having negative signs. Okay, the velocity should have positive signs. So we're going to have compute the integral over the entire domain, 0 to 6, of the absolute value of the velocity function, your t dt. This will help you determine the distance. Remember your continuum, SEAJ. If you differentiate position, you get velocity. If you integrate velocity, you get position. Okay, so that's why we're integrating velocity. If we integrated just the velocity function, that will give us the position function. But if we integrate the absolute value of the velocity, that gives us the distance, total distance. Okay, so we're going to be, in our calculator, we're going to be entering the integral from 0 to 6 of the absolute value of 2 sine e to the t over 4 plus 1. Okay, dt. Now, if you enter this in your calculator, let me just show you something real quick. In our TI-89 titanium, so we already have the velocity function entered here, so that makes our lives a little bit easier. So what we're going to do is just take out some pieces. Let's take out the 1/6. Get that out of there. Now, we're going to add the absolute value, okay? So absolute value, you go to catalog, ABS means absolute value. Okay, so the absolute value entire entry should give us what we want. All right, close that. Press enter, and then that's what you get. Okay, so notice how it entered it. Always please check your pretty prints to make sure it's consistent with your entry. So that's what we want. Looking good. So 12.5733 is the total distance. So total distance is 12.5733. All right, let's take a look at the D part. So for the D part, it says for 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So if a particle changes direction from left to right or right to left, it must come to rest at the point in time where the particle changes direction. So when is a particle, what do you know about the situation when a particle is at rest? If your particle is at rest, it's not moving, so its velocity is going to be 0. So v of t is equal to 0. So when is the velocity equal to 0? In order to figure this out, all we just simply do is we're going to graph the function and find the zeros of the function on the domain 0 to 6. So we're going to go to the Y menu, and then I'm going to enter the function. You're going to enter 2 sine e to the x over 4. Close that. Close the trig function and add 1. Enter. Now you have to be careful because in the graphing menu for your calculators, the independent variable is x, so don't enter t here or else you get a straight line. Just enter, the variables must always be in terms of x. Okay, so we have 2 sine e to the x over 4 plus 1. Let's go ahead and graph it. All right, so between 0 and 6, we're looking for the 0, so let's do a trace real quick. Trace here, F3, where is 6? Enter. 6 is right there, so this is the 0 we're looking for. So how do you find the 0? You go to your F5 menu, and under item number 2, 0, it asks for the lower bound. Let's pick 3. Upper bound, the points to the right of this 0, let's pick 6. Enter. And then we have x is equal to 5.19552. All right, so let's go ahead and write it down. v of t is equal to 0 when x is equal to 5.19552. Okay, so the question says we should find the position of the particle at this particular time. All right, so let's write this as t because our independent variable here is time. So t is equal to uh, this value. So when is t? When is the position equal to that? So we have the velocity function, and we know that we can apply FTC part 2 to that. If you remember, the integral from a to b of f prime of x dx is equal to f of b minus f of a. So this implies that f of b is equal to the f of a plus the integral from a to b of f prime of x dx. Now the relationship between the position and the velocity is that the velocity is the derivative of position. So if I made this x of b minus x of a, this will be v of x. Okay? Alright, so let's keep that in mind. So our expression here, we're going from 0 to this time. So we know that, let's write it this way. X of 5.19552 minus x of 0 is equal to the integral from 0 to 5.19552 of the velocity function, v of t dt. Okay, because v of t is a derivative of x of t. All right, so if I wanted to get this position when the time was 5.19552 by itself, I'll just add x of 0 to both sides. So I'll have x of 5.19552 equals x of 0. We already know that is 2 in the problem, so 2 plus the integral from 0 to 5.19552 of the velocity function. Let's see what's the velocity function. It's up here of 2 sine e to the t over 4 plus 1 dt. Okay? Alright, and when you plug it in your calculator, you're going to get 14.134. Okay? So that's that. So thanks so much for taking the time to watch this presentation. Do feel free to subscribe to our channels for updates to other cool AP Calc prep tutorials such as this. And please post a comment to let us know what you think about this presentation. More clips can be found on math.serve.com/calculus. Thanks again for watching and have a wonderful day.